about this for a second. The iron flowing through your veins right now, the oxygen you're breathing in, the very structure of your bones. Where do you think all of that actually came from? Because if we go back to the very beginning, right after the Big Bang, none of it existed. Back then, the universe was just this massive, terrifyingly quiet space. No stars, no galaxies, no light. Just an endless, freezing void of darkness. Scientists call it the cosmic dark ages, but honestly, it was just a dead universe. But here's the crazy part. Even in that absolute nothingness, an invisible force was already working behind the scenes. Gravity, slowly, quietly, it started pulling atoms together. And before we knew it, the very first lights in the cosmos turned on. Now, these weren't like our sun. These first stars were absolute monsters, massive, brilliant, and burning through their fuel like crazy. Gravity didn't stop there, though. It kept pushing, spinning billions of these stars together, weaving them into this giant cosmic web of gas and dust. Over millions of years, dark matter acted like a sort of highway, guiding these infant galaxies until they smashed into each other, forming the massive galactic clusters we see today. This was the golden age of the universe. Stars were being born 10 times faster than they are today. The cosmos was alive, glowing, and expanding. But there's a catch. The exact same force that created these magnificent stars was also setting them up for a pretty violent end. You see, when these giant stars finally ran out of fuel, they didn't just fade away. They collapsed under their own weight so violently that they ripped holes in the fabric of space itself. That's how black holes were born. And over time, these things grew into absolute giants. We call them supermassive black holes, and they sit right at the center of almost every galaxy, including our own. They're like the dark engines of the universe, controlling the fate of billions of stars. But if a star gets too close, it's over. The black hole's gravity will literally tear it apart piece by piece, swallowing it whole. It's wild to think that the very thing that gives a galaxy its shape is also its ultimate predator. But here's where the story gets really personal for us. Most stars in the universe are small, and when they die, they just cool down and quietly disappear. But that top 1%, the heavyweights, their deaths change everything. When a massive star dies, it goes out in a spectacular explosion called a supernova. And this is the beautiful part. Over its lifetime, the intense heat inside that star's core acts like a cosmic kitchen, cooking up heavy elements like carbon, iron, and silicon. When it explodes, it scatters all of those ingredients across the empty void of space. If those stars didn't die, the universe would just be a boring expanse of hydrogen gas. Their destruction was quite literally the sacrifice needed for anything else to exist. So, let's jump to about 4.5 billion years ago. Out in the middle of nowhere, on the edge of the Milky Way, a quiet cloud of dust gets hit by the shockwave of a nearby supernova. That shockwave causes the cloud to spin and collapse. At the center, a new star ignites our sun. And from the leftover debris swirling around it, a battered young rock forms, Earth. But back then you wouldn't recognize it. The early Earth was a living hell. It was just a ball of molten lava bombarded by asteroids with an atmosphere full of toxic gas and acid rain. It looked completely dead. It felt dead. But deep down, something incredible was brewing. As the planet finally started to cool down, massive oceans formed. And deep at the bottom of those oceans, away from the toxic air, cracks in the crust started venting heat and chemicals into the water. And right there, life found a way. The very first single-celled microbes appeared. For 3 billion years, these tiny organisms were the only ones here. But they did something amazing. They started consuming sunlight and pumping out oxygen. They literally changed the atmosphere, paving the way for complex life to evolve. Every plant, every animal, and every human being alive today goes back to those deep ocean microbes. We aren't just visitors standing on a rock looking out at space. We are space. We are the universe experiencing itself, made entirely out of leftover stardust. Thanks for hanging out and traveling through time with me today. If you love digging into the mysteries of our cosmos, hit that subscribe button for Neuroverse. Until next time, keep looking up.